Hey everybody, this is day 2 of our solving rational equations notes. We're going to finish up this top section 5 and 6, and then we're going to do these two bottom ones here on our second section of air quotes less easy ones, which I personally think are just as easy, but I know sometimes we struggle a little bit with our least common denominator. Okay, we're gonna move on to number 5 now. We're gonna do this one together because it is the next step up, and then you will try this challenge one. So I'm going to go ahead and draw my cross multiplication arrows. That'll give me x times x plus 4 on the left and negative 5 times x minus 2 on the right. Remember, my first step after this is to distribute to get rid of my parentheses. That gets me x squared plus 4x on the left and negative 5x plus 10 on the right. What I want to do now is get all my x's to one side. As you can see, though, if I were to do that, I'm going to move this over here, I would still have two terms that have x. Hopefully you can kind of see this starting to look like a quadratic equation. Because I have two terms that have x, I am going to have to actually factor. So I'm just going to move everything to one side at once because I need to be set equal to 0 to be able to factor. So I have a negative 5. I'm going to add 5. Put it right there because it's adding to that x term. That would give me a 0 pair. And then I have a positive 10, so I'm going to subtract that 10 as well. I'm going to squeeze it right there because it has no other constant to subtract from, so it's not going to connect to any of the other ones. It'll just look like this. There we go. Hopefully that helps you see what happened here. These cross out to make 0. Those cross out to make 0, so I have 0 left on the right. That was the goal. Here, this is the only one with x squared. These were like terms. They both had an x. They could be added together. And this little minus 10 didn't have any 1 to add to, so it just came down here. Now, I'm still trying to find my answer. What I'm going to do is factor what I have, just try to find the answer for x. I have a trinomial, so I'm going to label ABC. I'll make my multiply add chart. I have a times c is negative 10, and then add to the middle, which is positive 9. So I'm looking for a pair of numbers that multiplies to make 10. So I could do 1 and 10 or 2 and 5. And adds to make 9, so that'd be 10 and 1. Specifically negative 1, because they multiply to a negative, and remember they add to the sign of the bigger number. Perfect. Now I'm going to write down my answer. So I would have x plus 10 times x minus 1 equals 0. Perfect. Now I'm just going to solve each of these. So they both are equal to 0. So I'm just going to go ahead and do each one at a time and find my answer. So x equals negative 10 is one of my answers. And then x equals positive 1 is the other answer. And the last thing I have to do, just like before, no difference from over here, is check and make sure I didn't accidentally pick one of my restricted values as my answer, because that's not possible. So I'm looking for an extraneous solution. I realize I've never shown you that word. Extraneous solution is what it looks like. There you go. That's the phrase I keep saying. Now, look here, we just want to see if I plug this in to make sure it wouldn't give me 0 in my denominator. So obviously for x, neither of these are 0, so this side would never be 0. Over here, though, I want to make sure negative 10 minus 2 is negative 12, and then 1 minus 2 is negative 1, so we're good. Okay, so go ahead and pause. Try number 6. I know it's a challenge. It's not the worst, I promise. I can come back when you're ready or when you have gotten as far as you can. I just want to pop in here real quick just to make sure we didn't get trapped in that first step. Here's what you have after the first step. We cross multiplied to here, and technically 2 steps, I guess, and then we distribute it out. And here, when we distribute these, this is just a normal binomial multiplication. You just do double distribution. You multiply everything from the first set of parentheses times everything in the second set. And then here I just combine my like terms. So that gets me to this. Now you would just do the same thing we did over here, where we get everything to one side set equal to 0. Okay, pause again, finish, and come back. Is the rest. You should have gotten x equals 3 and x equals 6 as our two answers. Neither of them are extraneous. I didn't mean to not give you any that weren't, but here we are. So if I were to just double check, remember, I'm trying to make sure I didn't accidentally make my restricted value, my answer. So I plug 3 in here, I would get 12, so we're good. Plug 3 in here, I would get 2, we're good. And then check 6, this would give us 15, and that would give us 5. So as long as we don't get 0 in the denominator, our answer is solid, it's not extraneous. And there we go. Okay, let's go to the last type, or the second type, I guess. How to solve a rational equation, level less easy. I personally don't think it's actually less easy. I think they're the same kind of easy, but sometimes we get a little trapped in least common denominator, which is why we have it named like this, just so you don't get spooked about the least common denominator. So step 1 says determine the least common denominator, the LCD, of all the fractions in the equation. If you do not have multiple fractions on one side of the equation, you can go back and do the other steps over here. So we're only doing this step here if we have, sorry, multiple fractions or a fraction and a constant term on one side, like that. Okay, so I'm trying to find my least common denominator and put it over here. LCD. Remember, the LCD has to be the denominators multiplied, and we want to do the least of everything we have. So over here I have a 7x, here I have an x, here I have a 7. If I were to multiply this one by 7 and this one by x, then they would all have the same denominator of 7x. So that would be my least common denominator there. Step 2, multiply every term in the equation by the entire least common denominator. So I'm going to go like this. I'm just going to multiply by 7x like that. Doing little arrows here. I'm multiplying it by everything. This says here, this will eliminate or cross out all of your denominators. Be sure not to miss any factors that do not cancel out, as they are now part of your equation. So on this first one here, if I were to multiply this one times 7x, these would cancel, right? And I would just have x plus 8 left. If I go to this one, I'm multiplying this one times 7x, right? The x's would cancel, and I would just have negative 9 times 7. Like that. And then over here on this one, I'm multiplying this one times 7x. The 7's would cancel, and I would have 4 times x, like that. Now I'm just going to simplify where I can. So I have x plus 8 minus 9 times 7 is 63. 4 times x is 4x. Okay, we just finished up 3. It was distribute to get rid of our parentheses. And then step 4, move all variables to one side, then use inverse operations to solve for x so you can isolate. So I'm going to move all my variables to one side. I'm going to move this variable over here just because I want to get a whole number, or a positive number, sorry. And I'm also going to combine these two because they're both constants, so they can be added together. Not going to lie, don't know 8 minus 63 off the top of my head, so we are going to look it up. No shame, no shame. 8 minus 63 is negative 55. 4x minus x is 3x. And then my last step to isolate, I'm multiplying by 3, so I'm going to divide by 3. And I don't think that can simplify. Obviously, we're going to try. We have negative 55 divided by 3, and that gives us negative 55 over 3. So that's the most simplified answer. This is the one we would turn in. And then we're going to double check and make sure that we didn't accidentally pick our restricted value for our answer. So I'm going to come back up here and see if I were to plug this number in here, would it give me 0? Obviously not, because it's not 0, right? If I were to plug it in here, it would just be negative 55 over 3. And over here, it would just be 7 times negative 55 over 3. And there we go. I do want to show you, if you are confused on this part, I'm going to write down here what it actually looks like. I didn't want to make it too congested, but just to show you what it looks like without the shortcut that I showed you a second ago. Here's what it looks like that we're doing. So these cancel, that's how I got the x plus 8. These x's cancel, that's how I got negative 9 times 7. And then these 7's cancel, that's how I got 4x. That's how I got to right here, right there. I just crossed out what did cross out. Remember, if you have anything on the top and the bottom, I can cancel out and make 1. And that's what was left over. Okay, so I know it's a big step. Go ahead and try number 8. The worst you can do is not get it and then come back. So pause, see if you can get any distance of space to the question, then come back. Our last one here. I had a least common denominator of 3x. So I multiplied everything times 3x. For this one here, the 3's would cancel, and I would have just negative 1 times x left. For this one here, my x's would cancel, and I would have 3 times negative 6 left. And then for here, the full 3x would cancel, and I would have 3x plus 2 left. And then from there, same steps as before on the other type, or the other like steps of solving. We're just going to get rid of those parentheses. Sorry, that was an in. Do not follow those arrows. Sorry, here and here. Sorry. And then I would do the opposite operations, or sorry, inverse operations to get everything by itself. And my x is negative 5. Last thing I'm going to do is make sure I didn't accidentally pick one of my restricted values. I just plug it back in here. Negative 5 would not give us 0 there. It would just give us negative 5, or here it would give us negative 15. So we're good to go. Okay. Next, I'm just going to show you. I do want you to see one that has an extraneous solution. So I'm going to pause. I'm going to come back real quick with a question for you to look at. I have returned with the question. This one has an extraneous solution. There's no way for you to know that yet. I'm just telling you to know that because I looked it up. So what we're going to do, same thing as before. If we have more than just a fraction on each side, like we do here, we have a constant term here. We need them all to have the same denominator. Right now, my common one so far is x minus 1. If I were to just multiply this times x minus 1 over x minus 1, it would give me a common denominator of x minus 1. So I'm going to multiply the entire thing times x minus 1. There we go. That would cancel this one and that one because they both already have it on the bottom. And that would leave me with 1 minus 2 times x minus 1 equals x. And then we'll just solve from here. So 1 minus 2x plus 2 equals x. First step again was find the least common denominator right there. And then we multiplied it out. From there, here, we're going to get rid of all our parentheses that got me to here. And I just want to solve for x. So I'm going to put these two terms together. Then we get all the x's to one side. I'm going to move the smaller one like I always do, just because I have a habit of that. And then I'm multiplying by 3, so I'm going to divide by 3. And that gives me 1. So remember what we're doing always every time is checking, hey, just to make sure we didn't accidentally pick our restricted value because we don't exist at the restricted value because it's where the denominator is equal to 1. Oh, 0. Sorry, I looked at the 1. Where the denominator is equal to 0. So here, if we were to plug into our original equation, we have two denominators to look at. If I were to plug in positive 1, here, I'm just going to show you this first one here. If I were to plug in positive 1 there, I'd have 1 minus 1. And that would give me 0, which is not possible. So that means that this can't be our solution because it is the restricted value. So the answer is actually going to be no solution because the one that we thought was the solution was extraneous, meaning it doesn't exist. It was the wrong thing. And that's how you do those. There's going to be a couple of these in our practice I just want you to see, but they're not going to be with this guy. They're going to be from these type up here. Okay, cool. See you later. Bye.